In this video, we want to begin discussing binomial probability distributions. Binomial probability distributions are those in which there are only two possible outcomes. So when we look at binomial experiments, they are some in which you only have two possible outcomes, but they also have to meet some other criteria. One thing that they have to do is the experiment is performed a fixed number of times. So I can't just say, we'll do 10,000 or maybe we'll do 50,000. I have to know exactly how many times I'm going to run this particular experiment. Okay? Each repetition is going to be called a trial. So we're looking at the number of trials that we do, such as flipping a coin. If I flip it 10 times, that means that I have 10 trials that I'm looking at. The trials must be independent. This means that whatever happens on the first trial has no bearing on what happens on the second trial. They're completely independent of each other. We have no conditional probabilities in this particular case. They're also mutually exclusive. You either have to be what we call a success, or you have to be a failure. You cannot be in both categories. And the probability of the successes is fixed. Again, whenever I'm looking at flipping a coin, the probability of getting ahead is always going to be 1/2, or 50% of the time. So X is going to be called a binomial random variable. So the binomial random variable is going to be represented by X. It is what we're looking at. It's the number of successes in the trial. So we have to identify what is a success, what is a failure in each trial. N is always going to be the total number of trials. It's always been our sample space, lowercase n. P, lowercase p, is the probability of a success. And then if you recall that all probabilities have to add up to 1, so 1 minus p will be the probability of a failure. Because remember, you either have a success or you have a failure. You can't be in between. X denotes the number of successes of n trials. So X has to be less than n. So if we have 10 trials, I can't have 11 successes. I can only have 10 at maximum successes. Let's look at example 1. We want to determine which of the following are binomial random variables. And for those that are binomials, we want to state the possible outcomes and what the values of n and p are. So let's look at part A. An experiment in which a basketball player who historically makes 80% of his free throws is asked to shoot 3 free throws, and the number of free throws made is recorded. So in this case, we're talking about free throws in a basketball game. Do we have a success? Do we have a failure? Well, what are your options for what happens with a free throw? Either you make it or you do not make it. So since we have two options, we either have make or not make, that gives us the binomial because we have one or the other. Well, we want to know the number of free throws made. So that means that X is going to be the number of free throws made. What's the probability of X? What we'd call a success is going to be that we make the shot. The probability of making the shot, well, what's the probability of him making a shot? It was 80%. So that's 0.80. And how many times is he going to do this? He's going to do it 3 times. So our sample size is 3. Now let's look at part B. The number of people with blood type O negative based on a simple random sample of size 10 is recorded. So let's think about blood types. There are multiple blood types, but we have one specific that we have. So we're either type O negative or we're not type O negative. So since this is either we're type O negative or we're not type O negative, this one is still a binomial. When we look at it, our sample size, well, that's 10. That's okay. We also want to look at what our success is. Success would be considered having type O negative. So we have type O negative. The probability of a success, lowercase p, is one of those where we have 0.07. Now let's look at part C and see what's going on here. A probability experiment in which 3 cards are drawn from a deck without replacement, and the number of aces are recorded. Recall that whenever we have without replacement and then go from there, our probabilities are not the same. If the probabilities are not the same, we no longer have a binomial. So this is not a binomial since we don't have the probabilities being the same for each possibility. These are not independent events. So I'd highly recommend you looking at some of these, trying to identify whether it's binomial or not, and then also trying to see if you can identify its probability. And let me know if you have any questions.